Okay guys, so we're going to talk a little bit about proving similar triangles or congruent. So remember the stuff we did with congruent triangles with SSS and SAS and all those types of things. We're going to do something similar now, except we're doing it with similar triangles instead of congruent triangles. So a couple things to remember, just to compare congruent and similar. The symbol for congruent, remember, is an equal sign with a tilde over top. The symbol for similar is just the tilde, no equals. Now the definition of congruent triangles, the definition for congruent triangles is when all sides equal and all angles are equal. Okay, now on the flip side, a similar triangle, okay, triangles are similar if all angles are equal, just like congruent, but the sides are not equal, okay? All the sides, you might remember from the last stuff we've been talking about, all sides have to be proportional. Okay, got to be proportional. Now the scale factor. The scale factor for congruent triangles is always going to be 1. If they're congruent, then the sides don't change, so the scale factor is just 1. But for similar triangles, the scale factor is either going to be less than 1. That looks like an angle sign. Let me make sure that's a less than sign. So it's either going to be less than 1 or it's going to be between 0 and 1. So to say between 0 and 1, we'll say it's going to be greater, I would say x has to be greater than 0 and less than 1. So something between 0 and 1, a fraction, 1/2, whatever. So now how to prove when it's congruent. Okay, remember we had 5 theorems. We had SSS. If all the sides were the same, then it's congruent. Or we had side, angle, side. If you had 2 sides that were the same and the angle in between them was the same, it was congruent. And then we had angle, side, angle. 2 angles and the side in between them. And we had angle, angle, side. And then we had hypotenuse, leg, which was just for right triangles. Right? So we had 5 of them for congruence. But for similarity, luckily we don't have as many. For similarity, you have side, side, side. So in this situation, if the 3 sides are proportional, then you know the 2 triangles are similar. You also have side, angle, side. So that's good too, that we're already familiar with. So if the 2 sides are proportional and the angle in between is congruent, because remember we said for similar triangles the angles are congruent but the sides are proportional. So now these sides don't need to be the same as each other, they need to be proportional. Okay, so you could have all 3 sides proportional, you could have 2 sides proportional and the angle in between congruent, or if you just know 2 angles are congruent, then you know the 2 triangles are similar. So those are some things to remember about congruence and similar that are a little bit different. So let's do some examples here. So let's look at these 2 triangles and determine, are they similar or not? So right here we're looking, we're given 3 side lengths and 3 side lengths. If we know if they're similar, we're going to figure out if the sides are proportional. So to figure out if they're proportional, we need to write a ratio of the side lengths and see if all the ratios are equal. Okay, so let's take a side from this triangle. Any of the sides will work. Let's start with the 5. Okay, so we put 5 over the corresponding side of the other triangle. So as you can see, these are color-coded for us, which makes it easier, but they're not always going to be like that. So you've got to be able to identify this is your short side, and over here your short side is 4. So it'll be 5 over 4, which whenever you reduce that is going to be 1.25. Alright, now we take our other sides and do the same thing. 12. Okay, it's important that since we did 5 on top, our other ratios have to have the side lengths from this triangle on top also. So we'll say 12 over the side that it corresponds to, 9.6. And when we type that in the calculator, we also get 1.25. So that's good. So far, they're proportional. And then do the third side, 13 over 10.4. Divide that in the calculator, and we get 1.25 again. Awesome, so all the sides are proportional, so we know the 2 triangles are similar. So what we'll say is triangle, we'll do a similarity statement. We're going to say this triangle is similar to this triangle. So we know we're going to have a similar symbol in here and another triangle symbol. So what are we going to call this triangle? Well, you can start with anything. Let's say we start with A, and we can say ABC. Just go alphabetical order. So triangle ABC. So we can put anything on this one, but right here we got to make sure that we put the letters that correspond to these letters. So whatever the first letter is here, the angle that corresponds to the first one right here has to be the first one here. So what corresponds to angle A? Well, it's where the pink line and the orange line meet. So pink line and orange line meet right here at D. So we're going to start this one with D. And then we went to B, which was the right angle, so that's going to be F. And then our top angle up here is E. So triangle ABC is similar to triangle DFE, and we'll say we know that by SSS, because all three sides were proportional. Alright, so let's go on and do another one. So let's look at one with SAS. Okay, so this time it's a little bit less work. You just got to see if two sides are proportional. So right here, let's do 5 over, which side does it correspond to? 7.5. And when we divide that, we get 2/3, okay, or it reduces to 2/3, which is 0.6666, yeah, whatever, you can put lines over it, however you want to do it. All right, and then we check the other one, 7 over 10.5, and we get the same thing, 2/3 or 0.6 repeating. Okay, so our sides are proportional. Now the angles in between, okay, it's got to be the angle in between the two sides has to be congruent. So the angle in between these sides is 70. The angle in between these sides is 70. So we would say something like angle H is congruent to angle K. So we know they're similar because the sides are proportional and the angles in between the sides are congruent. So we can do our similarity statement. Triangle, we'll say GHI, similar to triangle. What corresponds to G? That's L. And we went to H next. That's where the two lines meet. So LK, and then J is the last one. So we know this triangle is similar to this one. How do we know that? By SAS. All right. Okay, let's do one more, and then we'll practice a little bit. So AA similarity. Okay, so this one's really simple. All you've got to see is that two angles are the same, and you know they're similar triangles. So right here we've got 50 and 50. So angle O is congruent. Remember, the angles have to be congruent. The sides have to be proportional. So we will use a congruent statement here, equals with a little squiggle over it. So angle O is congruent to angle P, and angle N is congruent to angle R. Because of that, so we can say triangle, let's do MNO, similar to triangle. M is the side that we didn't know the angle, so that's going to be this one up here, which is angle Q. So we'll say angle triangle Q, and then we did N, which is the orange one, so that's going to be R on the other triangle, and then O. Not O, sorry, P. So triangle MNO similar to triangle QRP by angle postulate. All right, two angles are congruent, so we know the triangles are similar. All right, so let's actually apply this. Okay, so on these problems, you're going to have to remember, you know, some of the other theorems that we use. You know, vertical angles, parallel lines like alternate interior angles, those types of things to be able to do these. All right, so let's look at this first one. I'll do these 4 with you and let you guys practice the next 3. So right here, what do we know just by looking at this picture? Well, we can see we got 2 lines across, so we know this angle. We know this angle and this angle are congruent because they're vertical angles. All right, now remember, these arrows mean these are parallel lines. So, because they're parallel lines, we also know, because alternate interior angles, we know this angle is congruent to this angle. All right, so, well, now we've got an angle is congruent and an angle is congruent. So we can say they're congruent by angle. All right, so our triangles, we could say triangle EAB, similar to triangle EDC, because we went from the one angle mark to two angle mark to the one that we didn't have an angle mark for. Alright, so that's how we know by AA. Okay, let's look at number 2. Well, we see an angle is congruent and a side is congruent. Alright, remember that last time it's congruent. But we don't need any other information. We need to know that the other sides are something like that. So right here we don't know for sure that these are similar, so we can just say no, not enough information, something like that. Let's look at number 4. Okay, so right here you've got angles that are vertical, so we know those are congruent, and then these two sides are congruent. Well, an angle and a side, that doesn't help us. We either need to know 3 sides are proportional, we need to know 2 angles are congruent, or we need to know 2 sides and the angle in between. We don't know anything else about these other sides, so again, this is not enough info. Let's look at number 5. So here they gave us some actual side lengths. So we know these angles are congruent because they're 90-degree angles. So let's check the sides and see if they're proportional or not. So we've got 28 over 14. If we do the big triangle, that equals 2. Now look at the other side, 10 over 5. What's 10 over 5? That's also 2. So the sides are proportional. We've got this side and this side, proportional to this side and this side. So because of that, we also have an angle in between that is congruent. So we can say, yes, these are similar. So triangle TUV, similar to triangle UWX by side angle side. So I'm going to go ahead and pause it and let you guys try the next ones on your own, and then we'll go over. Alright, so right here on number 3, it's a little bit tricky. You've got to know that because these lines are parallel, angle L and angle O are congruent because they're corresponding angles. They're both in the same location at the where the intersection of the parallel line and the transversal meet. So this one's, obviously they're below the parallel line and above the transversal, so in that same spot at each intersection. So they're corresponding, which means they're congruent. So that was one tricky thing you had to know. And then also, this big triangle and this little triangle share this angle. So obviously, that angle is congruent for the little triangle and the big triangle. So then, by knowing that the big triangle has this angle and this angle congruent to the little triangle's 2 angles, we know the 2 triangles are similar by AA. So again, the tricky part here also, you got to make sure you get the letters in the right location. So if we say LNM, we've got to say O because it corresponds with L, N because it corresponds with itself, and then P because it corresponds with M. Now on number 6, you knew the lengths of all the sides, so we need to see if the sides are proportional. So I did 30, which is the longest side for the big triangle, over the longest side for the small one, which is 15. That gives me 2. And then the other sides are both going to give us a ratio of 26 over 13, which is also 2. So I don't need to do this one twice. I know it's going to be the same for the other side. So I know that the 2 triangles are similar by SSS. So if I say LMN, L is the angle between the big side and the side to the right of the big side. So even though this was upside down, I got to use 15, which is the big side, and the angle to its right if I flipped it around. So that would be angle O. So O corresponds to angle L. So we'd have to say OQP is similar to triangle LMN. Now number 7, very similar to number 6. Okay, you got to divide the large side on the big one by the large side on the small one. Divide the small side on the big one by the small side on the small one. And divide the medium side by the medium side. And they all happen to give us a ratio of 6. Therefore, the sides are proportional. So just like number 6, these 2 are similar by SSS. If we do ABC, notice A is the point between the 2 biggest sides. So we got to do H because it's the point between the 2 biggest sides on the small triangle. And then when we go to B, we went down the middle side. So we got to go down the middle side to go to our second coordinate, G. and then of course F at the end. Alright, so now I'm going to go ahead and pause it again, let you guys try the 2 word problems coming up. Okay, so in these word problems you actually get to draw some pictures to help you out a little bit. So we got a tree 30 feet tall, casts a shadow that is 12 feet long, and Brad is 8 feet tall. Pretty tall boy. Wish I was 8 feet tall, be nice. And we want to know how long is Brad's shadow. So we draw our picture, and once we draw a picture, what we can do is make these into triangles. And once we've got triangles, we know that these triangles got to be proportional. The sun always makes proportional triangles with shadows. So since they're proportional, we can set up a proportion to solve for x. So you can set these up a lot of ways. You can do the height of the tree over the height of the boy equals the shadow of the tree over the shadow of the boy, which is what I did. Or you could do the tree over its shadow and the boy's height over its shadow. You could set them up a lot of different ways, okay? But you got to make sure that you don't set up like 30 over x and 12 over 8 or something like that and mix them up. So you got to be careful. Make sure you put them in the right places. Sometimes if you draw words, it'll help. So like right here, I could say tree over boy. So I make sure I put the tree's numbers on top and the boy's numbers on bottom, and make sure they correspond. So if I put the tree's height right here and the boy's height right here, then maybe I could label up here also height, and maybe right here shadow. So this is the tree's height, this is the tree's shadow, this is the boy's height, this is the boy's shadow. Maybe you want to use the words like that to help you get them in the right locations. That's fine. So once I do that, I cross multiply, get 30x equals 96, divide by 30, so x equals 3.2 feet. That's how long the boy's shadow is. And on this one, I've got 2 triangles. The lengths of EFG are 144, 128, 112, so I just draw a triangle and label it, and do the same thing for the other one. But what they tell us is the smallest side of QRS is 280. So what I need to do is make sure I put 280 on the side that would correspond with the smallest side for EFG, since they're similar. So since I put 112 down here on the bottom, I'll put 280 on the bottom. Since 112 is the smallest, 280 is going to be the smallest. And then we want to know what's the longest side. So the longest side is 144 on the small one, so that would correspond to this side, which will be x. So I'm going to use those 2 numbers with these 2 numbers to set up a proportion. So I do that, cross multiply, and then divide, and I get x is 360. So this side length right here for QR must be 360. All right, appreciate y'all's time. Time to practice.